strong force of attraction within molecules of solid, but in liquid the molecules slide over one another. So that's what happens to liquid. The molecules slide over one another. But in gases, the molecules are widely spread. Widely spread. So they have the weakest force of attraction. Is that taking? You can see the molecules of gases now. All of them are moving apart at random. Do you get that? So for gases, all the molecules are moving apart. But for liquid, the molecules can slide over one another. But for solid, they are well packed together because the force of attraction is very, very strong. Do you get that? So this one I can add to this one. Molecules of solid vibrates about their mean position. Is that taken? So the molecules of solids vibrate about their mean position. They want to leave, so they go giggle. So they are vibrating about that mean position. But when they now gain enough energy that you can break that position, then you talk about melting points. Then they melt. So that is what we have. Now another thing is compression. Molecules of solid cannot be compressed. You can't force them together. Molecules of solid. Is that taken? Molecules of solid cannot be compressed. No. Molecules of liquids, no, except under some certain condition. Why molecules of solid, of gases? Yes. You can still push molecules of gases together, but you can't push molecules of solid together. You can't fill a bucket with solid and you want to push it inside so that some other substances can come into play. So when it's filled, it's filled. You can't force it. But a gas, you can push it because your gas just occupy every available spaces. So I can bring all these guys together now. So if I bring all these guys together, then it will occupy a small space. Then you see that there is still enough space for other things to come in. But for this one now, when you push them together, there is no space for them to go to. So you can't push or compress them. Do you get that? You can't. How about degree of randomness? Entropy. So when you are talking about entropy talks about the degree of disorderliness. Which one is in the greatest order out of the three of them? Solid is in the greatest order, well arranged. But these ones, they are spreading everywhere. Do you get that? So we call that randomness. So degree of disorderliness is seen more in gases than in liquid and than in solid. So you can say that entropy is defined as degree of what? Disorderliness. Degree of disorderliness. Show you? And it goes from gas, degree of disorderliness is greater than that of liquid and greater than that of what? Solids. Is that taken? So that's about the states of matter. So please, in case you need some notes, you can try and write more on the differences between the states of matter. Is that taken? To some of you that might want to still be writing WAEC or so, try and get a pure note from those textbooks I recommended, the differences. But I'm trying to explain them now. And I'm not moving too fast yet because since morning now, I'm still on states of matter. Normally, if I want to move too fast, I would have completed this thing. So, but I hope you get what we have been saying. Matter is anything that has mass and can occupy space. And matter exists in three major states, which are the solid, the liquid, and the gases. And we're trying to differentiate those three states. So now, let's move on to change of states. Change of state is talking about one state of matter can go to another state. You can move from one state of matter to what? To another state. So I can go from solid to liquid. I can go from liquid to solid. So I can go from liquid to solid. I can go from solid to liquid. I can go from liquid to gas. And I can go from solid to gas. And I can go from gas to solid. I can go from liquid to gas, then gas to liquid. So that's the change of states. So a change of state is talking about the change in phase of the states of matter. So one state of matter will change to the other. So I can go from solid to liquid. Is that taken? So when you go from solid to liquid, there is a name we call it. When you go from liquid to solid, there is a name we call it. So depending, we also have what we call your heating curve that shows how your solid can go to liquid, and the liquid can also go to the vapor state when you are heating it at a particular temperature. So the solid can go to liquid. At this point now, both your liquid and solid will be in equilibrium. Then everything will melt and get to the liquid phase. Then after that, everything goes to the liquid and the gaseous state or the vapor. Then you now have the vapor. So as you continue to heat it up, as temperature is increasing, so your temperature is here. So as the temperature is increasing, then it will get to a state the temperature will remain constant. At that point, we call it the melting point. Then the temperature will start increasing again. Then it gets constant. At that point, we call it the boiling point. So we'll talk about that briefly. Now, let's look at the first change of state here. Also, for some liquid, for some substances, we also have a state in which when the solid is going to the liquid state and going to the gaseous state, at the liquid state and the gaseous state and the solid state, let's say this is the solid phase, this is the liquid portion of it, and this is the gaseous portion of it. Plotting against temperature and pressure too. So you can go from solid to liquid and to gas. That point, this point where the solid, gas and liquid are together, we usually call it the triple point. So we'll look at that. So let's look at the first part of it. What is this one saying? You want to go from solid to liquid. I want to melt a substance. I heat it up, then I want to melt it. So going from solid to liquid is called what? What do you call the process? I can't hear you now, I'm waiting. You should know this. It's called what? Melting. So going from solid to liquid is called melting. Is that taken?
Yes.
Then going from liquid to solid, what do you call it? Freezing. So you put your liquid in the refrigerator and it freezes. So we call this part freezing. Is that taken? Then when you are going from solid to gas, normally you expect a substance when you start heating it is a solid. You expect it to go to liquid first before going to the gaseous state. But this substance, when you heat it, directly from that solid state, it goes to the vapor state. Then, when it goes directly from solid to the vapor state, what do you call it? Sublimation. Very good. So it's called sublimation. Is that taken? So the change in state of matter directly from solid to the vapor state without passing through the liquid phase, we call it sublimation. So it goes directly from solid to gas without passing through the liquid phase. So you heat a substance solid, so it disappears from solid to gas. Is that taken? Without passing through the liquid. So it did not. Many of you have seen your camphor before. Abi, camphor is kept in your wardrobe or something to send away some of those insects. So when you keep it there and you go there, do you see the camphor melting? No. But you just notice that the camphor will continue to disappear little by little, will continue to reduce. Do you get that? So that is such an example. So when you heat the camphor now, it just disappears into the vapor state. So that is called sublimation. And not only camphor, that salt I brought that day too, that was what happened to the salt. So when you look at it, examples of substances that will sublime. So let's look at examples. We just talked about camphor now, Abi. Camphor is an example. Some of your air fresheners too, they can also disappear too. Then ammonium chloride. Ammonium chloride. This can also disappear too when you leave it open. Which other one? Dry ice. We call it dry ice. Dry ice is solid CO2. Is that taken? Solid CO2 is dry ice. So what else? Naphthalene. Naphthalene is another example. Maybe that spelling is wrong, so please check that. Naphthalene. We have which other one? Iodine crystal, Abi. Iodine crystal. So don't forget, all these guys, they can sublime. That is, they can just go to the gaseous state without passing through the liquid phase at all. Find that, are you following? So they can go to the gaseous state without passing through the liquid phase at all. So they can ask you for examples of substances that will sublime, or in your options, how do you separate a substance that will sublime from a substance that will not sublime? So you have to understand all those procedures. Then, when you are going from gas to the solid state, what do we call it? In some textbooks, you see it as condensation. But that is another word for gas going to liquid phase. So the process is called deposition.